So in this video, we will learn about sign conventions of components of what forces. We learn about sign conventions of what components of what forces. Sometimes you have a force and you say the force is negative, the force is positive. So how do we know that? So this video will tell us how to know this. So let's look at this. So let's say I have this as this here. So this will be my plus x. That's a positive x axis. And this will be my plus y. And then here will be my negative y. Here will be my negative x. So this is all you need to know whether the component of a force is what positive or negative. So I'm going to write this here in a simplified form. So I'll say that for the y part, if the force is moving up, it is what positive y, and then if it is moving downwards, that's negative y. So they are all vertical. Okay, so let's go to the horizontal one. If it is moving in this direction, that's positive x, and then in an opposite direction, that's what negative x. So it's just that represented here. Okay, so this is what will tell you whether the component of the force is what negative or positive. So let's say I have a force here. Okay, I have this force here moving in this direction. The component of the forces must also move in this direction. So this will be the x component because it is horizontal, and then the y component will be this one because it is what vertical. And they are all moving the same direction as what the main force. You can't have the main force moving this direction, then you can't have an x component moving this way. Okay, having an x component moving this way, and then the y component also moving this way. This contradicts the law. Okay, so the component of the forces must also be in the same direction as what as the main force. So this is not accepted. Okay, so now let's move on to what you're doing. So since this is the horizontal, this will be the x component of this force, and this is the vertical part, so that will be the y component. So how will we know whether this component is positive or negative? In order to determine this, let's come to that's for the x part. Let's come to this side. So looking at this part, which of these force is moving the same direction as this? So that tells us that is this force, right? So that one is what positive. So in this case, x should be what positive. And looking at the y2, and come to the y part too, this force is moving upwards, and then if it is moving upwards, we have what positive here. So that tells us that the y part also be what positive. So that's how it is done. So let's say I have another force system. Okay, something like this, and then this force is moving downwards. So it will have components, right? So the vertical component, which is also moving in the same direction, and then the horizontal component, okay, which is also moving in this direction. So okay, let me clean this part and then make it better. Okay, so let me make it here. Okay, so this is the main force. Okay, so this force has a y component and then an x component. So now you are going to tell whether what the components are positive or negative. So now let's focus on the x component. So let's come to this side. Look at the direction of what this force here. It is moving in what this direction. So when you come here, you see that this is also moving in this direction. That tells us that the x component of this force here will be what negative. So this will be negative. Let's consider the y part too. It is moving downwards. So let's come to this side also. When it is moving downwards, it is negative. So that tells us what the y component is also what negative. So we see how it is detected. Alright, so let's try another example. So let's say I have a force going this way. Okay, so this is the main force. Let me make it F. It will have x and the y component. So this will be my x component, and then the y component also will be vertical. Okay, so this is the x, and then this is the y component. So this force also has x and then y component. So you are going to determine whether what the components are positive or negative. So you are going to determine for what each of them. So first, let's consider the x. Let's look at the direction of what the s component. So this s component is moving in this direction. So when you come here, that tells you that it is moving in the negative x-axis direction, so it will be negative. And then considering the y to it is moving upwards, so when you come here, that tells us that the y part will be what? Positive. Okay, so this is how to tell whether the component of a force is what? Negative or what? Positive. So now let's take a typical example. So I have a force here, and then this is the s component, this is the actual force, then this is the y component of the force. So let's say I have an angle here to be 30 degrees. Okay, and then the main force F is 100 Newton. So you want to find the component of what this force. So looking at the direction of this force, the s component will be Fx, and will it be positive or negative? So looking at this direction here, that tells us that the s component will be positive. Out of the y component also, looking at the direction here, it tells us that what it will be what? Positive. So that what Fy here. So the if you want to find the s component, we can use the, the, the cosine and then the sine. Okay, so for the s component, since it is what adjacent, I can see that what cosine of 30 degrees equals what Fx equals Fx over the hypotenuse, which is what the 100. So the s component of this force, which is Fx, will be equal to what 100 cosine of what 30 degrees. Okay, so do the same for the y part also. The y is opposite, so we can say sine of 30 degrees equals opposite, which is what Fy over hypotenuse, which is what 100. So the y part will be Fy equals 100 sine of what 30 degrees. So that's how to go about this. So now let's take another example. Let's take another example. I'm going to use the same values, but I'll change the direction of the force. So let's say I have a force moving in this direction. Okay, so this force will have x and y components. So the x part will be the horizontal part, and then the y part will be the vertical part. Okay, so I have my Fy here. Okay, so I have my Fy here, and then I have my Fx here. And let's see, this angle is what 30 degrees. Okay, and then the actual force is 100 Newton. So you want to find the components of what this force. So first of all, let's consider the direction of the component. So the s component is moving in this direction, since the resultant force is also moving in this direction. So looking at this, that tells us that the s component is what negative, because it is moving what this direction. And then looking at the y too, it is pointing downwards. So this is here. So that tells us that the y part will also be what negative. So with this, let's find the component of the force. So the x component will be, the x is what adjacent, so that will be cosine of 30 equals minus Fx over the magnitude of the force, which is what 100. So I'll have minus Fx equals 100 cosine of what 30 degrees, and from here you can divide both sides by negative 1. So at the end I have what negative 100 cosine of what 30 degrees. So that will be the x part. You will do the same for the y part. So the y is also what opposite. So I can see sine of 30 degrees equals what opposite, which is what negative Fy over hypotenuse, which is what 100. So I have negative Fy is equal to 100 100 sine of what 30 degrees. So I can divide both side by -1. So then I have Fy to be equal to what? -100 sine of what? 30 degrees. So that be the y component of this force also. Okay, so let's try our hands on another example. So in this case, I have a force pointing downwards like this. So this is the force. Okay, and this force has a y component, and then also an x component. Okay, then put the main direction of the force at the top. So this is the main direction of the force. Okay, so to have the the y component, and then also the x component. Okay, so with this force, this will be the x component, and then this is what the y component. So let me make it Fy and then Fx. So let's say this is the actual force, which is what? 100 Newton, and then the angle here, let me make it 30 degrees. Because of the space there, that's why I decided to write it here. Okay, so let's make it 30 degrees. Okay, so now I want to find the x and then the y component. So first, let's determine whether what the component will be positive or negative. So let's take for the x. So for the x, we come to this side here. Look at the direction of this. Is it the same as what this force that we have here? This axis here. So that tells us that what the x component will be positive. And then looking at the y2, it is pointing downwards. So when come here, we have this here. So that tells us that the y component is what? Negative. So now with this, we can go ahead and find for the component of the force. So for the x part, it is what? Adjacent. So that will be cosine of 30 degrees. It is adjacent. That was fx over hypotenuse, which is what? 100. So the fx, which is the f component of this force, will be what? 100 cosine of what? 30 degrees. So we do same for the y part too. So the y is what? Opposite. So I'll say sine of 30 degrees because the opposite, which is what? Negative Fy over the hypotenuse, which is what? 100. So at the end, I have negative Fy to be equal to 100 sine of 30 degrees. So I divide both sides by -1, both sides by -1. So at the end, I have what? Fy to be equal to negative 100 sine of what? 30 degrees. So that's how to determine what the component of forces. So you just have to know about the direction of what this force. There may be cases where you have 3D, where you have other dimensions here. Let's say here is Z. Okay, so if it is Z and this side is given to the positive to be the positive Z axis, okay, this side will be the negative for the Z axis. So any force that will go in this direction will be negative, and then any force that will go in this direction will be positive Z. So it's the same approach that you are going to use here.